Picard's method using Maxima. We know that Picard's methods is used to solve ordinary differential equation of first order and first degree. That is, we can solve this is a numerical technique to solve a differential equation of the type dy by dx is equal to f of xy with initial condition y of x0 is equal to y0. Now to solve this differential equation using Picard's method, we can write this differential equation as dy is equal to f of xy dx. Now integrate this equation from y0 to y dy is equal to x0 to x f of xy dx. So here the integration on the left hand side is y from y0 to y equal to x0 to x f of x y dx. So this is equal to y minus y0 integration x0 to x f of x y dx. This is same as y equal to y0 plus integration x0 to x f of x y dx. So now substitute. Now to solve this integration, we substitute here, or we assume y is equal to say y equal to y0 to find the value of y1, and therefore so y1 is equal to y0 plus integration x0 to x f of x y0 dx. Okay, so this is the formula to find the value of y1 using Picard's method. So the formula for y2 is equal to y0 plus integration x0 to x f of x y1 dx. Okay, and so on. So in general, yn plus 1 equal to y0 plus integration x0 to x f of x yn dx. For example, if we suppose we want to solve a differential equation, find the solution of dy by dx is equal to x plus y square with initial condition y of 0 equal to 0 and find y of 0.3. So here the first value of given, this is the ordinary differential equation with x0 is equal to 0 and y0 is equal to 0, and we want to determine y of 0.3. So the first iteration y1 is equal to y0 plus integration x0 to x f of x y0 dx, and therefore f of x y0, that is, this is equal to y1 is equal to y0 is 0 plus integration 0 to x f of x0 dx. Here f of xy is equal to what? X plus y square. F of xy, this is the value of f of xy. So f of xy equal to x plus y square. If you compare dy by dx is equal to here, if you compare this differential equation with dy by dx is equal to f of xy, so the value of f of xy is equal to x plus y square, and therefore f of x0 is equal to y1 is equal to 0 to x f of x y0, which is equal to x dx. So this is equal to x square by 2 from 0 to x, and therefore y1 is equal to x square by 2. Now if you substitute here y1 of 0.3, then this is equal to 0.3 bracket square divided by 2. So it is equal to it is equal to 0.00540. Now next, this is the first approximation. Now we are going to find y2. So what is y2? y2 is equal to y0 plus integration x0 to x f of x y1 dx. So y1 is what? X square by 2. X square by 2. So y2 is equal to y0 plus x0 to x f of x square by 2 dx. Now what is f of xy? F of xy is equal to x plus y square. X plus y square. So in place of y, we are going to substitute x square by 2. y0 is 0, x0 is 0. So y2 is equal to integration 0 to x plus y square. So it is y square means what? X square square. So it is x raised to 4 divided by 4 dx. So this is equal to x square by 2 plus x raised to 5 divided by 20, and the limit is from 0 to x. So this is equal to x square by 2 plus, if we substitute the upper limit, the lower limit is 0, upper limit is what? X square by 2 plus x raised to 5 by 20. Now to find the value of y in the second iteration, this is what? y2. So y of 0.3 is equal to 0.3 bracket square divided by 2 plus 0.3 raised to 5 divided by 20. So it is approximately equal to 0.0451. Okay, so again, since in the first iteration, for the first iteration we obtain the value of y is 0.0450, or in the second iteration we obtain 0.0451. So if you observe, these two iterations are correct up to 3 decimal places, but we want our answer should be correct up to 4 decimal places. So we are going to calculate the next iteration. So for y3 is equal to y0 plus x0 to x f of x y2 dx. So this is y3 is equal to y0 is 0, so it is 0 to x f of x. What is y2? y2 is equal to x square by 2 plus x5 by 20 brackets x5 by 20 dx. Since f of xy equal to, what is f of xy? F of xy equal to x plus y square, and therefore y3 is equal to integration 0 to x x plus y square. So what is y square? It is x square by 2 plus x raised to 5 divided by 20 bracket square dx. So now if you simplify this, then it is equal to y3 is equal to integration 0 to x plus square is x4 by 20 x square x raised to 4 divided by 4 plus you multiply these two, so it is x raised to 7 divided by 20. Since a plus b bracket square is a square plus twice ab plus b square, now it is x raised to 10 divided by 20 square is 400 dx. So now if you take integration, this is equal to x square by 2 plus x raised to 5 by 20 plus x raised to 8 divided by 160 plus x raised to 11 divided by 4400, and the limit is from 0 to x. So it means what? If we substitute here lower, for the lower limit the value is same. For upper limit, y of x is equal to x square by 2 plus x raised to 5 divided by 20 plus x raised to 8 divided by 160 plus x raised to 11 divided by 4400. Okay, so now if we calculate the y of 0.3, then this is equal to 0.3 bracket square divided by 2 plus 0.3 raised to 5 divided by 2 plus 0.3 raised to 8 divided by 160 plus 0.3 raised to 11 divided by 4400. So this is equal to, if we calculate this, then y of 0.3 is equal to 0.0451. So now you can observe at third iteration and the second iteration. What is second iteration? Second iteration is also 0.0451 and the third iteration is also 0.0451, and therefore our answer is equal to the y of 0.3 is equal to 0.0451. Now we are going to use maxima to calculate the to solve Picard's method. So first we want to assign here f of xy is equal to x plus y square. This is what f of x plus y square. Now x0 is equal to 0, y0 is equal to 0 y0 is equal to 0 x0 is equal to x0 is equal to 0 and y0 equal to 0. Now next y1 is equal to y0 plus integrate. Now in Maxima, to calculate the integration, we use the command integrate f of xy0 in the variable x from x0 to x. Okay, so this is the value of y1. I am going to write here y1. So it is what, x square by 2. Now the value of y is equal to, at 0.3 is equal to, substitute. Now I want to substitute 0.3 for x in y1. Now you can see here it is 0.045. So the first iteration it is 0.045. You can see here, and in Maxima also the first iteration is 0.045. Now for the second iteration, I am going to copy this, Control C, Control V. y1 is equal to, now y2 is equal to y0 plus integrate f of x y, instead of y0 now write down y1, and if you enter here it is x raised to 5 plus 10x square divided by 20. So this is the same as here. You can check the y2, it is same as x square by 2 plus x raised to 5 by 20, which is same as x raised to 5 plus 10x square by 20. If you write here rad simp, okay, you will get the same output. Sorry, this is a simplification form, not simplification, more simplification is not possible. So now we want to substitute, the value of x as 0.3 in y2. So it is what, 0.04512. So you can check here, it is 0.0451 in the second iteration. Now for the third iteration, again if you copy this, third iteration, Control C, say here y3, in place of y1 we are going to replace y1 by y2, shift enter. Then this is what y3. So what is y3 here? Y3 we obtain, it is x square by 2 plus x raised to 5 by 20 x raised to 8 by 160, x raised to 11 by 4400. So if you simplify this, you will get such a type of an equation. And if you substitute here, if we substitute the y is equal to x is equal to 0.3 in y3, then we get 0.0451. okay, now you can see, you can observe these two answers, the value of two iterations are correct up to 1 2 3 4 5 decimal places, 5 or 6 decimal places. These are correct up to 6 decimal places. And you can here we also solve them manually, and you can observe this is also correct up to 4 decimal places. So the answer by using Maxima is also same, it is 0.045121. This Maxima answer is correct up to 6 decimal places, 1 2 3 4 5 6. Here also you can check 2 3 4 5 6. okay, so hope you understood the Picard's method.